Hi everyone, welcome to Testbed India. So this is the first session of alligations and mixtures. Before delving into this method, let me clear this point to you. Alligations and mixtures is not a separate topic. It's a method. It's a different method. With this method, we can solve some models, some problems in different arithmetic topics such as percentages. We can also solve problems in ratio proportions, in averages, right? So alligations is a method to solve some kinds of problems in arithmetic topics, right? So let's get into the traditional method of alligations and the formula method and then the general rule. If we consider a traditional method, let's say you have 20 liters of 20 liters of a mixture. So this mixture consists of water and water and alcohol in the ratio 4 is to 2. Now you are removing 5 liters of this mixture, right? 5 liters of this mixture, and you are adding 5 liters of water. So when you are removing 5 liters of this mixture, this 5 liters consists of both water and alcohol in the same ratio, in 4 is to 2 ratio. So when you are removing 5 liters from 20 liters, the remaining is 15 liters. This 5 liters that you are removing consists of water as well as alcohol in this ratio, right? But after removing 5 liters, you are adding only water, you are not adding alcohol. So please understand this division here, right? This is important for traditional method. Whenever you are solving traditional method, whenever you want to solve alligations through the traditional method, this division, this clarity must be there. This traditional method has no limitations. This can be applied whenever alligations is applied, but this formula method has some limitations, right? And we also look into general method. We will solve problems, but until then just remember this: whenever you have a mixture and whenever you are removing some quantity of that mixture, the quantity that you are removing will be in the same ratio of the mixtures ratio, right? This ratio, okay? Please remember this. And coming to the formula, if we want to use the formula, let me write this formula now, which is the final quantity by initial quantity, that is equal to 1 minus number of liters by capacity of it. See, final quantity by initial quantity is equal to 1 minus number of liters by capacity of it. That means capacity of the container, whole power t. T means how many times the process is repeated. So if we want to apply this formula, there is one condition, which is the quantity removed must be equal to the quantity replaced. Okay, so the quantity removed must be equal to the quantity replaced. For instance, if 20 liters of a mixture is removed and 20 liters of water is added, so from a mixture, let us take this mixture has 50 liters or anything. So 50 liters of this mixture, from this 20 liters of the mixture is removed and 20 liters of water is added. Water, or let's say a spirit, is added. Okay. So here if you observe 20 and 20, this quantity is same. So whenever this quantity is same, we can apply this formula. Okay, we can also solve by this traditional method, but if this is the case, formula is easier to calculate. Formula we will get the answer within no time. And what about the general rule? Let me erase this. And if we move to the general rule, you must have seen this structure somewhere in your life. So this, on the left hand side we have cheaper value, right? On the right hand side we have the costly value, the expensive ones. At the center we have the mean value, that is the average value. And whenever we are calculating the ratio, we'll just subtract this costly value minus this value, average value, right? And this side we will subtract average value from average value and cheaper value, right? Average minus cheaper. So what if you subtract like this, cheaper value minus average value? Well, you get negative value, you get a negative value. So we must do like this in order to avoid any confusion. See, when can we apply this alligation method? When we have two quantities, when these two quantities are getting mixed, and we get the when we get the third quantity, right, from this mixture, then we can apply alligation method. It can be a ratio proportion, it can be a problem from percentages, it can be a problem from averages, whatever the concept might be, we can apply this alligation rule in those situations. And whenever we are applying the alligation rule, we can follow these methods, any one of the methods, but the formula method has some limitations. Let's move on to the first question. We will solve different models. We'll solve different models, and in the upcoming videos we'll move on to some more advanced models. So first question is, a vessel contains 80 liters of spirit, 20 liters of this liquid is removed and replaced with water, 20 liters of this mixture is again removed and replaced with water. How much liters is present in the vessel? See, we have a vessel. What is the meaning of this? We have a vessel and it contains 80 liters of spirit, right? 80 liters of spirit. 20 liters of this spirit, this liquid, is removed and replaced with water. So if we are removing 20 liters from 80 liters, the remaining is 60 liters spirit, and we are replacing that 20 liters of spirit with 20 liters of water, right? With 20 liters of water. So 20 liters will be water and 80 liters will be spirit. The quantity is same. Here at first we have 80 liters. Now also we have 80 liters, right? So what is the ratio? 3:1. Spirit is to water ratio is 3:1. Now what happened? 20 liters of this mixture is again removed and replaced with water. Okay, so this mixture we have 60 plus 20, this mixture, again from this mixture 20 liters is removed. So in the previous slide we learnt about replacing. Whenever from this mixture some quantity is removed, whenever some quantity is removed, that removing quantity will have the same ratio as per the original quantity, right? So here the ratio is 3:1. When this 20 liters of this mixture is again removed, this 20 liters contains spirit and water in 3:1 ratio, right? So 3 parts of 20, 3 by what is the quantity of spirit in 20 liters? 3 by total parts, 3 plus 1, 4 into 20, that is 15 liters. And this one 1 by what about water? Quantity of water 1 by total, 3 plus 1, 4 into 20, that is 5 liters. So from this 60 plus 20 we are removing 15 liters of spirit and 5 liters of water. So this 60 liters, if we remove 15 liters, it becomes 45 liters, and this 20 liters from this, if we are removing 5 liters, now it becomes 15 liters, right? So 45 liters is the final spirit quantity and 15 liters is the final water quantity. What is the question here? How much water in liters is present in the vessel? Now what happened? This, after removing this, again the 20 liters is replaced only with water. No spirit is added, only we replaced that with water. So this is the final result till removal, but again we have to replace with 20 liters of water. So just add 20 liters of water, nothing, no spirit is added. So 20 plus 15, that is 35 liters is water and 45 liters is spirit. The total quantity is same, 45 plus 35, which is equal to 80, right? So in this way we must calculate. This is a simple problem. So this is the traditional method, right? This is the traditional method. What about the formula method? See, as we discussed, if the replaced quantity and the removed quantity, right? If this one, which is the removed quantity, and this is the replaced quantity, if both are same, this is 20 and this is 20, we can use the formula method, right? So what is the formula? Final quantity by initial quantity is equal to 1 minus number of liters, right? Number of liters divided by capacity of the container, whole power t. Okay, here what is the final quantity? Final quantity is, we have to calculate the final quantity. So final quantity is, initial quantity we will take this to the other side. So initial quantity is 80. So 80 into, so 80 liters, right? 80 liters of spirit. 1 minus, what is the number of liters, total number of liters that is being replaced? 20, right? So every time 20 is being replaced. Number of liters replaced. Okay. 20 by, what is the capacity of the container? 80. So 80 is the capacity of the container. And how many times it is getting replaced? This is the first time and this is the second time, right? So 2 times we are replacing. So 2. So now calculate this. 80 into, take LCM, and we will get 3 by 4 into 3 by 4, and after calculation we will get 45 liters. What is this 45 liters? See, we have taken at first we have spirit, right? Spirit, we have completely spirit. We did not take the value of water. We do not know the value of water. So 45 liters will also be the value of spirit. And as 80 liters is the total quantity, 80 minus 45 is equal to 35 liters. This is the quantity of water. See, this one and this one is equal, right? So this is the formula method and this is the traditional method, right? A gold worker has two qualities of gold, one of 12 carats and the other of 16 carats. In what proportion should he mix both to make an ornament of 15 carats purity? So we discussed the general structure of alligation method, which is the cheaper quantity comes on the left side, the quantity which is expensive comes on the right side, and center we have the average quantity, average value, mean value, right? So in the same way here we will take, so out of between 12 and 16 carats, which one is the cheaper one? I mean cheaper in the sense the less qualitative product. 12, right? So 12 we will take on the left hand side and 16 here. So what is the mean value? 15. So just subtract 16 minus 15, here 15 minus 12, this becomes 1 and this becomes 3. So 1 is to 3. In what proportion should he mix? So in 1 is to 3 proportion, in this proportion he must mix both these quantities of gold in order to get 15 carats. So 12 carats and 16 carats of gold must be mixed in this ratio, in 1 is to 3 ratio, in order to get 15 carats gold purity. Okay. In two vessels A and B, there is mixture of water and mixture of milk. The ratio of milk and water in these vessels is 5:2 and 8:5 respectively. In what ratio of milk and water in the new mixture becomes 9:4? If the new mixture becomes 9:4, right? So we have 5:2 and 8:5. Two vessels we have, two vessels A and B. In vessel A, the ratio of milk and water is 5:2. In second vessel, we have milk and water in the ratio 8:5. So in what ratio these two must be mixed to get a new mixture of 9:4? So 9:4, right? We cannot directly subtract like this. We cannot directly take like this. So in these kind of problems, we must either take the value of milk or the value of water. Anything is fine. Anything is okay. If we consider the value of milk here, in the first case we have 5 by, what is the total parts? 5 plus 7, 5 plus 2, which is 7. In the second case, the quantity of the part of milk is 8 by total parts 8 plus 5, that is 13. And in ratio also, take the milk. If we are taking the part of milk, then we must take the part of milk in ratio as well, in this average as well, right? So 9 by 9 plus 4, 13. Now you can directly subtract. If you subtract 8 minus 8 by 13 and 9 by 13, we get 1 by 13. And if we subtract these two, we get, which is 9 by 13 minus 5 by 7, we get, after else take LCM, and we'll get 2 by 91. So 1 by 13 is 2 by 91. 1 by 13 is to 2 by 91, 13, 7. So 7:2 is the ratio. So in this ratio, the milk and water can be mixed. These two can be mixed to make a new ratio 9:4, right? New mixture in order to make the new mixture 9:4. Two vessels contain mixture of milk and water in the ratio 4:3 and 3:5 respectively. The ratio of volumes if quantities from the two vessels to be mixed together so that the new mixture may contain same volume of milk and water. So here what do we have? This we can follow the same method as we followed the previous question. Either take the value of milk or take the value of water. So in the first case we have milk as 4 and total parts 4 by 7, and second case we are considering only the quantity of milk, right? So 3 by 8. The ratio of the volumes if quantities from two vessels to be mixed together so that the new mixture may contain same volume of milk and water. So same volume of milk and water means milk and water must be in this ratio, right? Milk and water must be in this ratio. So this is the mean value. 1:1 is the mean value, and here we are considering only the milk value. So here are the average, the mean value. Also we must take the milk value. So 1 by total parts 1 plus 1 is 2. Now subtract 3 by 8 minus 1 by 2, and here 1 by 2 minus 4 by 7. Now take the LCM, we get 1 by 8 and 1 by 14. Now cancel it, 7:4. So this is the ratio of the volumes if the quantities from the two vessels to be mixed together, right? So that the new mixture will contain the same volume, the same ratio of volumes, milk and water, right? So this is the ratio. In what ratio tea at rupees 240 kg should be 240 per kg should be mixed with tea at rupees 280 per kg, so that on selling the mixture of rupees 324 per kg there is a profit of 20%. So in this case, see, 240 per kg is the cheaper one and 280 per kg is the expensive one, right? So 240 we will take on the left hand side, 280 on the right hand side. This is cheaper one, this is expensive one. And 324, should we take 324 here as the mean price? No, we shouldn't take 324 here, because if we observe here, 240 is the cost price, 280 is the cost price, but 324 is not the cost price, it is the selling price. See, observe this statement. So that on selling the mixture, so 324 is the selling price. In alligations method, please remember this. If cost price, if this one and this one are in cost price, this shouldn't be in selling price, this must also be in cost price. Okay, so what should be the value here? We do not know the value of cost price. We know selling price value, which is 324. So just calculate this. There is a profit of 20%. So if there is a profit of 20%, then we have to add 20 to 100, right? So if 100% is X, then 120%. See, why are we taking 120%? Here 120% profit. So 100 plus 20. If it were 20% loss, we would take 100 minus 20, which would be 80. So here profit. So we are taking 120, 100 plus 20. 120% is 324. So 120 by 100 of X is 324. Calculate X. X will be equal to 270. What is this 270? This 270 is the cost price, the mean price. Now you can directly subtract. After subtracting, you will get 10 and 30. So the ratio is 1:3. So these two quantities, right? These two quantities of tea must be mixed in 1:3 ratio, so that the resultant price of the tea per kg will be 270 rupees, right? 270 in the sense this will incur 324 rupees, which is 20% profit. So this 1:3 in this ratio, these must be mixed in order to get this 20% profit. In what ratio must water be mixed with milk worth rupees 12 rupees per liter, so as to produce a mixture worth rupees 10 per liter? Here what is the price of milk? The price of milk is 12 rupee, right? 12 rupee per liter, but we do not know the price of water. So what can we do in these situations? In these situations, we can assume the price of water to be 0 rupees. 0 rupees, because we can assume water to be free of cost. So if we assume like this, then which one will be cheaper, water or milk? Water. So put the value of water, price of value on the left hand side as it is cheaper one, and value of milk on the right hand side, which is 12 rupee. And here we must mix them in a in some ratio in such a way that the resultant mixture must worth 10 rupee per liter. So 10 will be the mean value. So just subtract this, we will get 1:5 as the ratio. So in this ratio, the water and milk are to be mixed. In an examination, out of 1000 students, 70% boys and 80% girls are passed. If total pass percentage was 76%, find the number of girls. So we have 70% boys, right? So we have 70% boys and 80% girls. This is the lowest value, this is the highest value. So we are taking it on the left hand side and right hand side respectively. So this is boys and girls percentage, 70% and 80%. So these must be, if the total pass percentage was 76%, so the average, the mean is 76%. So take the subtract this 4 and 6. So the value or the ratio is 2:3. But this is the ratio of boys and girls. We are asked to find the number of girls. So 2:3. So what is the girls part? 3 here. So 3 by total parts, 2 plus 3, which is 5 into what is the total strength? 1000. So into 1000, that is equal to 600. So 600 are the total number of girls. What about boys? Remaining 400 are boys. Right? If rupees 85 is divided among 100 students such that each boy got a rupee and each girl got 50 pies, find the number of girls. Okay, so 50 pies, each girl got 50 pies, each boy got 1 rupee. So 1 rupee means 100 pies, right? 100 pies and 50 pies. If we assume this all 100 students as boys, then the total number of the pies that they get is, because each boy gets 1 rupee, right? 1 rupee means 100 pies. So 100 into 100, which is 10,000 pies. And if we assume all the girls to be all these 100 students to be girls, then 100 into each girl is getting 50 pies. So 100 into 50, that is equal to 5,000 pies. This is for boys, this is for girls. We are assuming all the 100 to be boys, and here we are assuming all the 100 to be girls. And what is the mean one? 85 rupees, right? So 85 means 85 rupee into 100 pies, because each rupee the value of each rupee is 100 pies. So 85 into 100 is equal to 8,500. Take the subtract now 3,500 and 10,000 and 8,500. This is 1,500. So the ratio is 7:3. So this is the ratio, but we must find the number of girls. The number of girls is 3 by 7 plus 3, which is 10, into total students, which is 100, that is equal to 30, right? So these are the total number of girls. How much water be mixed in 36 liter of milk worth ₹5 rupee per liter, so that the value of mixture is 3.60 rupees per liter. Okay, so in previous problem, in previous slides, we discussed a similar problem like this. Whenever we do not know the value of water, how do we know the value of water? In case in the question itself it is mentioned like take value of water to be 3 rupee per liter or 5 rupee per liter, then we can consider that value. But here nothing is mentioned, so we can calculate, we can consider the value of water to be 0 rupees, right? So what is the value of milk? This is 5 rupee, and value of water is 0, milk and water, right? And what is the median price? Median price is 3.60, right? So take the subtract now 3.60. This is equal to 3.60, and 5 minus 3.60 is 1.20. So the ratio if you convert this, the ratio would be 18:6. So in 18 liters of milk, water added, what is the quantity of water added in this 18 liters of milk? 6 liters of water is added. So in 1 liter of water, in 1 liter of milk, what is the quantity of water added? See, this mixture has 18 liters of milk and 6 liters of water, right? So in 1 liter of milk, how much water is added? Take the value of water, 6 by value of milk, 6 by 18. What is the total quantity? 36 liters, right? 6 by 18 into 36. 12 liters. 12 liters is the water added in 36 liters of milk. In 1 liter it is 6 by 18, but what about the 36 liters of milk? So in 36 liters of milk, if we want to calculate the quantity of water added, just multiply that with 36, right? How many kilos of sugar at 50 pies per kg must a man mix with 25 kilos of sugar at 35 pies per kg, so that by selling the mixture of 44 pies per kg he gains 10% on the outlay? Fine. So what is the cost price of the mixture? 50 pies, right? The value of sugar. And what is the value of sugar in second case? It is 34. So take 34 here and take 50 here, right? Cheaper one, expensive one. Here gaining 10%. Profit gained is 10%. So x 10% of x, 110% of x, the 10%, this 44 pies. So just calculate this. 110 by 100 into x is 44. X will be equal to 44 by 110. So this will be equal to Cp will be equal to, Cp means x will be equal to 40. So we can take 40 here and do the subtraction. We will get 6 is to 10. So here we will get 10 is to 6, and the ratio would be 5 is to 3. Therefore the sugar of 50 pies per kg to be mixed is, what is the part? 3 by total parts, 5 plus 3, which is 8. So how many kgs of sugar at 50 pies per kg? So this is the value of sugar at 50 pies per kg, right? So this must be mixed with 25 per kg. Okay, so 3 by 5 into, this is mixed with 25 per kg, so this will be equal to 15 kg. So 15 kg must be mixed. 15 kg of sugar at 50 pies must be mixed. A hospital uses a mixture of salt and water at rupees 7.62 per liter. This mixture contains 5% salt. Another mixture containing 75% water costs rupees 7.82 per liter. How much does the patient pay if he buys 5 liters of mixture containing 18% salt? Right, the first mixture, right? So we have two types of mixtures. This mixture costs 7.62 per liter, and this one costs 7.82 per liter. Here in the first case 5% is the salt, that means 95% is water, whereas in second case we have 75% water. 75% water means remaining 25% is salt, right? So take any one value, either take the value of salt or take the value of water, right? So here if we take the value of salt, it is 5 in the first case, 25 in the second case, and what is the median? What is the mean value? The average value? 18%, right? 18% salt. So 18% is the salt. So here this is the salt in first case, salt in second case, salt of this median, this average. See, if we want to take the value of water, we can take like this. In the first case 95% is water, in second case 75% is water, and the mean value, if 18% is salt, the remaining 82% is water, right? So this is the value of water, percentage, right? So if we want to consider water, we must consider all the three values as water. If we want to consider salt, we can take all the three values as salt. Fine, just subtract now. What do we get? We get 25 minus 18, which is 7, and 18 minus 5, that is 13. So 7 by 13 will be equal to, in the second case we have, let me erase this, 7.62 rupees, 7.82 rupees, 7.62, 7.82, and we have we don't know the value or the cost price, right? So let that be x, right? So what is the value here? 7.82 minus x by x minus 7.62. now just cross multiply and we will get x as 7.75 per liter. So what is this? This is the price of 1 liter, but we are asked to find out the price of 5 liters, right? So 7.75 into 5, just multiply this, we will get rupees 38.75, right? This is the price of 5 liters. How many kilos of custard powder costing rupees 42 per kg must be mixed with 16 kg of custard powder costing rupees 60 per kg, so that 20% may be gained by selling the mixture at rupees 60 per kg. So 20% is the gain. So 20% means 120%, because 100 plus 20. 120% of x is equal to, here what is x? X is the cost price, right? X is cost price. 120% of some cost price is equal to 60 rupees. So 120 by 100 into x will be equal to 60, and calculate x, we will get as 50, right? 50 rupees. Now take this 42 in the first case and 60 in the second case. What is the mean? Mean is 50. Subtract, we'll get 10 and 8, and if you simplify, I will be getting ratio as 5 and 4, and 5 by 4 will be equal to, and if we assume x as the required quantity, here how many kilos of custard powder be mixed? So this required quantity, if we assume this to be x, then it must be mixed with how much? 16 kilos of custard powder, right? So x by 16, and cross multiply this, we will get x as 20 kilos. What is this 20 kilos? This 20 kilos of custard powder costing rupees 42 per kg must be mixed with 16 kilos of custard powder costing rupees 60 rupees per kg, right? So that he will incur a profit of 20%. An alloy of copper and nickel contains 65% copper. A second alloy contains copper and nickel in the ratio 17:3. In what ratio should the two alloys be mixed so that the new mixture contains 4 times as much copper as nickel? So in the first alloy, so whenever we consider alloy, we have two types, right? So the first alloy, we have 65% copper, right, and 35% nickel. So the ratio is 65:35. Whereas in second alloy, we have 17. Copper is to nickel ratio as 17:3. So copper is to nickel ratio as 17:3. Here 65 is to 35. So if we further simplify 65 and 35, we will get ratio as 13:7. And what is the proportion of copper in first alloy? It is 13 by value of copper, 13 by totals, 13 plus 7 total parts, which is 20. So 13 by 20. And in second alloy, the proportion of copper is 17 by total, 17 plus 3, which is 20. So 13 by 20 and 17 by 20. And also the proportion of copper in the resulting alloy. See, how do we calculate the resulting alloy, the proportion of copper in the resulting alloy? Here these two alloys are mixed in such a way that the new mixture contains 4 times as much as copper as nickel. So 4 times of copper as much as nickel. So 4:1 is the ratio, and the proportion of copper in this one is, that means when these two are mixed, we will get this one, right? So this proportion is 4 by 5, right? So simply take the subtraction. So after calculation, we will get the ratio as 1:3. A vessel is full of mixture of spirit and water, in which there is 20% of spirit. 5 liters are drawn off and the vessel is filled up with water. If the spirit is now 20%, find the total quantity in the vessel in liters. So let us assume the total mixture as x liters. So x liters is the total mixture. Let us assume like this. And here 20% of spirit. So this contains 20% of spirit. So 20 by 100. When 5 liters are drawn off, quantity of spirit removed. So when 5 liters are drawn off from this, so what is the quantity of spirit? So 20% of 5 liters. 20% of 5 liters is 0.2 into 5, that is 1 liter. So when 5 liters are drawn out of the 5 liters, 1 liter is the quantity of spirit, right? What about the remaining 4 liters? Remaining 4 liters is the quantity of water. So 4 plus 1 is 5. So we assume the total quantity to be x, right? So x is the total quantity, and we are removing 1 liter of spirit. So 1 liter is being removed. So 20% of x is the spirit. So as 20% of x is spirit, 20 by 100 of x minus 1 liter we are removing. So this is the remaining spirit. Complete quantity is x liters. Out of this x liters, 20% is spirit. Now what happened, out of this 20%, we removed 1 liter of that spirit. So out of this 20%, 1 liter is removed. So we are subtracting 1 from this 20%. So this is the remaining quantity of spirit. And also it is given that the spirit is now 12%. So if the spirit is 12%, so it will be 12 by 100 into x, right? So 12% is the present spirit. So we can directly equate these two. And if we calculate, we'll get x as 12.5 liters. What is this? This is the total quantity in the vessel. So this is the total quantity, total liters in the vessel. So these are different problems in alligations and mixtures. In our advanced arithmetic schedule, we will solve all the advanced questions, advanced level questions, right from percentages to alligations and mixtures to simple interest, compound interest, right? So we'll cover ratio, proportions, averages, and everything except time and work, time, speed, and distance, because we are taking 3 days to complete time and work and time, speed, and distance. So we will complete all the models from basic to advanced in those 3 days, right? So time, speed, and distance, time, and work, we will be completing within the schedule. For remaining remaining arithmetic topics, we will be solving the advanced level questions from 26th of August, I think. So just look into that schedule once, the advanced arithmetic schedule. So we will be looking, we will be solving more advanced problems there. So these are the basic level problems. So in order to get notified, you can subscribe to our channel. Thank you very much and all the very best.